Never heard such a deafening silence. I never thought I would be so in vain. And the world can't revolve around your pretty face. Oh, but it should. It should. Yes, it should. They say the truth hurts, but you can't just give up hope. And I say I'm here for you if you ever need to let go. I've never won't let you falter on your own. And the world can't revolve around your pretty face. Oh, but it should. It should. Yes, it should. You're in this fight alone. You think your heart is made of stone. You don't have to be a lone soldier. Won't let you falter on your own. And the world can't revolve around your pretty face. Oh, but it should. It should. Yes, it should. They say the truth hurts, but you can't just give up hope. And I say I'm here for you if you ever need to let go.
Good morning, or whatever it is, wherever you are. I'm still catching up on sleep from the other night. I did do a little bit post-stream the other day. We were sort of untangled after a fashion, this thing. So I was trying to set up a time series that was this structure of like a current value and future values of things that had a start field. And the problem is that it kept trying to type it as, well, it's a type of A, which does not have a start field. We're going to then add a start field to it. So when I try to declare, a series of something that has a start field, that doesn't work so well. What I found is that I can declare it of a more generic structure, similar to how a list can be of anything. And then the functions, which specifically deal with start fields, then declare they have this additional restriction on them. You pass in a record that happens to have that in it first. Well, okay, A here is actually not the same as A here. It's the record without the start field. The big breakthrough with that was just separating this general idea of iteration, similar to how a list has a map operation on it. It can take any function. From the thing that applied the specific, the type-specific things to that. I'm still not sure that's the solution I like, though. well, it works, but I use the lets rarely enough when I'm doing this functional code that it makes me question if it is actually the way I should be doing it. Now, at some point, you're going to have to calculate this stuff, and at some point, you're going to have to calculate that stuff. One of the things I've thought about is instead of having state of each of these lists, sort of in this little structure that has to have this common property to it. Well, I'm still going to want functions over these types of lists, possibly. Of course, I might also want to be doing end times, and end times are a little bit different for each of them. Is that similar to, well, actually, no, it's not similar. Well, yeah, world merge takes a time. So similar to that, where we have a concept of the current time. You would have a method to give an ordinary list of these things. It'd say, well, our current object is the one where is the first element where the time is in where the given time is inside the start and end period. Which runs into the generalization problem that our end is different. And the next time is first figure that out and then go past that entry to figure out what the sort of next time event is. So I've thought about like trying to put all of these into some sort of generical, you make like a enumerated type that can hold all the different structures. And then also have a time value. You can put them all into one big list and just sort by the time value. You still have to do some extra checking for things that happened to be kind of at the same time. You could turn each of these lists into like start time, end time. Pass through that, trying to compress things that are like within 1 second or of each other or so. 1 second, 1 minute, whatever. Also, I've considered, or I'd rather I've just considered. No, I think the arc map selection uses a arc specific. It might be useful to have pre-built in. We build worlds. If we have a arc, we get a seed. Okay, so MSN was only coming from arc time, and that might have been. Oh, no, because the ends get rewritten. Okay. Yeah, so this is actually a problem we're going to have. In that if there was an arc, we use the arc MS end to create the layer. So I'm probably going to have to add a field. Uh, End time for that blog selection. So time doesn't really make sense here anymore because I'm not doing that series. All right, so you got a little bit of let too. And mostly pulling out. Okay, start, generation. Name with a little bit of stuff. Version arc. All right, so if we assume we could write the function. See, yeah. There's an idea. Just rewrite the top level function. I guess it's kind of the inner function. Well, it had to do the series wrapping. I might not need that wrapper. What would this look like if we did it as... And a better name for this. If we did it with time, we would have... Would I even want to use POSIX here? Really, I'm going to be dealing with milliseconds. And I'm not sure how I want to do that on the first pass. Then it would be list, age, list. List version. List arc. You'd probably still need an accumulator. Now, would you be the next time or the last time? Guess we'd have. We'd have to use the current time to skip past entries to the next entry. And then use that to select the new current value. More like last time. So we're still going to have some sort of next time thing. Ultimately, what we want to do is we want to call this again with a next time. So we still kind of have to do some lets here. And based on our next time, we need our next arcs somehow. And then so this had pre-selected the current. And this is a maybe next time. We probably still have to do some degree of lets in here, at least for this thing. Going to be key to that, and it's going to be, maybe I don't have to do that selection up front. This could be of course, I might do something with ends here. But we're still going to need at least that. And all of those can be maybes, so this is actually going to look very similar. This would sort of be like what? And it's going to be a similar operation. We get the next based on the current time, and then it's the head and the POSIX. And I mean that, well, I guess this isn't functionally any different. I mean, it might save us having this sort of extra data structure abstraction to keep track of the current value. Uh, blah, 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 blah. Next times. And yeah, it's going to look almost identical to this. At least if I pull the values out. Uh, the data structure probably could be done without. This form, because this is sort of stateful, we have to advance the structure to be able to get the current value of it. So this one could be done in line if we defined our operations that way. But what do we call you? I mean, maybe I do end up calling it series next time we start that code, but we have to do something and we'll develop that in the meantime. All right, so it might make some of this fit here. So current is going to take an int. Well, yeah, everything's going to be tagged now. As a time, and I guess we still call a series. And the thing we want to know is, since we don't deal with ends yet, oh, current is a singular value. But it's a maybe because it could be an empty list for all we know. So if Uh, oh, and you need the whole maybe thing. That's a definite time. If the time is less than, then no value is selected. This is almost a lot again. Do I need this one twice? But that's not a value. What if there is no head to the list? And arguably, that's nothing right there. So that's like a maybe head time. We could map that over the comparison. Turn it into a Boolean. Oh, this is current. This is not going to go full next time. The only thing... Since well, no, I do need to know... Well, okay, so this is not a structure which can guarantee its state. The other structure had a definite current value, although you didn't necessarily know anything about what that value meant. But if this is sort of maintained, and it might come down to, well, the Boolean value comes down to half of that. But we actually need to know, well, we need the return list head at some point. Time is less than. I could. Oh geez, how does this work as an operator? Because then you could do, with our default, is that if there is no head, and it's not in there. I just not really had time anymore. Which hardly even matters, because the else here is and I think this would mostly, like a with default, would only be not true when it was. But like, there's the case where it's not in range, so because we've not hit that point yet. We've got I'm starting to wonder if the other code's clearer. But for this one, we want to drop an entry and possibly recurse if the second entry no wait, if time less than if time greater than start time. I mean, that's how that works. We almost need to like just we do a local drop. Okay, so so this ends up doing a lot more lets inside the structure. Maybe that's because I was using this destructuring form to sort of get those local references before. Actually. No, you can't do list destructuring on function calls because you have no way to do multiple declarations. I mean, maybe that would make a function that would only work on empty lists. But we do have to handle empty lists at some point. Yeah, so I was trying to get rid of all of the lets up here, but this is kind of pushing it down to these sub-functions. So you're going to check the next entry. You're going to kind of discount the current entry because we're assuming a sorted set. So that gives us our next entry. Now what we're doing is essentially the same as this. So I'm wondering if I could just say, if that is in range, if I'm next, else, have not yet reached that point. It's just as is. That's sort of nice. It needs the let, but you could just repeat. Well, let's see if there's any problems with this part of the code. That one. Oh, no, I keep forgetting to download 19.1 too. We've got like an indentation error here. A argument error? Okay, yeah, that's mismatched. Probably that whole thing needs to be there. Okay, so you were a recursion. All right, I'm calling this last time. And undefined. All right, so the next time after this time, I guess the ultimate result of this is the actual time, isn't it? Well, no, it's a maybe. So this is, sort of implicitly using advanced thing. Of course, that would be a slightly different let where you first advance, use the head of that. If we advance and then call it current with the time, it's actually going to be nothing. So it would just be the head of that, all those lists. You would have to let all the intermediate values. No, and then you could not reuse that as the next list to process. Or would you, on the assumption that it would then get advanced? Right, because if you're then doing the advance at the top, the minimum time of that. Uh, but we're not necessarily using those values. Yeah, you essentially have to advance again the new time. So as a function in and of itself, we take the next entry after the current entry. This is time-based. Right, this says if it's in scope. Otherwise, it returns as is. um, hmm. The next entry is in scope. Stick with that, but that's in scope at this time. So this will always result in a list where the first entry is currently in scope. Isn't that the state we expect to be passed in? So the first state is probably going to be like time 0. And lists of times that are much greater than 0. Call this on the first round. We expect none of that to be in scope, so it will just run the list as is, and it will then be the head of the list. By advance at the end of one call, would we always be going into a state where and that would leave you in a state where time was usually passed there, but it counted as current. The next time is not going to be the list. So you would advance, because it won't do it unchanged if it's not there yet. And then it's just, we need this value instead of a comparison. Because the only sad thing here is that it's going to depend on whether we're advanced or not, which time we're looking at. So we sort of have to do that twice. So I guess there might be something to keeping that intermediate time around. Next time. Nope. Okay, fine. We'll have good, useful names then. And then we stomped on a name used somewhere else. There you are. Actually, you weren't used. Oh, I got you backwards. Uh-oh. A start. Well, I typoed something then. Yeah, we need a with a start POSIX. A with a start POSIX. And which we copied down to all of these functions. I copied too much, apparently. It just happened to be syntactically valid. You're 9. Ah, you might like an argument. Ah, yes. Oh, wait, yeah, I was doing a truth test there. I start POSIX, maybe start POSIX. Oh, you're not a... Type annotation on advance. Oh, okay. You were a little bit different. You are a maybe, you are a maybe. Millis to POSIX, POSIX to millis. Now, if this actually works. All right, so right now my entry point is this. So you are going to be yeah, if I did my arguments in a different order, I could sort of set that up as a curry. Huh? Oh. Just one, just one. And it's an infinite loop. Yay. We didn't actually adjust our time there. So the first time through, it's 0. Something got identified with a 1, which is like basically saying infinite. We're going to do one range at that. Probably some of my tests, at least one of my tests, needs to be equal then. The current value if time is greater than or you're probably equal to, because we want to say if we're there. Which will then end up affecting this. If we found something, then advance. And that doesn't do a comparison. Of course, now, if it's an infinite loop, I can't bring up the debugger to look at it. Looks like it's still an infinite loop. So where is, just to confirm that. Oh, did you not compile? You compiled. Supposedly. Yeah, reloaded too fast? Okay, I reloaded too fast. Oh. Maybe I reloaded too fast again. I mean, maybe the other one I also reloaded too fast. Oh. Nope, we did not actually remove our list here. Yep. All right. I think that was time one again. I guess it's possible that my comparison's backwards. It's always confusing how those binary functions work out. You know what? This is actually going to be in the documentation site. I don't know if they're going to show that form. Number, but it doesn't have this. Doesn't tell you which is which. Is there GNOME console? So if we do, I guess we're really concerned about like greater than. All right, 1, 2 is false. So we would say 1 greater than 2 is false, 2 greater than 1 is true. So that suggests the correct interpretation of that. Error? How is that different? Oh, because I typed an arrow in there and not a valid character. So if we just do greater than 1 applied to 2, okay, that is backwards. You cannot read it as typed in value greater than 1. It is exactly the opposite of that. This has to be read as time not as value less than or equal to time. I think for clarity, we may have to do one function here. Because that does not read well. We're trying to say we want the value where time is at least passed there. Still stuck on 1? Okay, compiled. Uh, and it's still just 1. I guess what we really need to do is something like okay, how about yeah, well, we're going to have lists here. So we've got current current 0 ages. Advanced 0 is not going to work so well. I need to know which of these is 1. Okay. Current is nothing. Biome layer just all the generation. Start equals POSIX 1. Okay, so you're R1, which means our next time is going to be 1. Uh, advance. I guess current and next time are really the only things we're going to be caring about here. So so we go to time 1. Pile jet. Okay, we get to a current, but next time has not advanced. So that's where our error is. Arr? Oh, maybe, do I have these backwards? The next time is in scope. Oh, that's kind of a double advance for one. I mean, this is just a list drop, not a. Well, we know what current is. That's a just, not equal to nothing. So we call this again, and that should not be up. Okay, next current is equal to nothing. Oh? Right, because we're automatically dropping one. So if current is this, the next one is going to be not valid. And we don't advance at all. But in that first pass, we've gone from 0 to 1. But if advance does not advance, which here it does not, then we never actually get to the sort of next, true next time. So maybe this is just a drop one. Except on the first pass, where we actually need to be looking at we don't drop anything if we're not even there yet. Current at 0, next current at 0. But we've not advanced to 1 yet. I don't think I've. Well, there's the implicit advance in list next time. The next current is nothing. We've got a next entry at that point. But it's not to 1. So I think I'm looking at advance in two different ways. One is I need to look beyond the current entry. And the other is I need to say, has the time actually reached that other entry? And when we have not yet reached any entry, I can't just do a drop one on it. What we would do initially is say, well, look beyond the current one. Do I have to advance? No, advance drop one still wouldn't work at the zero case. Which makes me not like this method at all a little bit. I was mostly looking at get it working and then compare how the code looks. Next time at time one, should be looking beyond the current entry. So that would be a check to see what? If the time is current, the given time is current, then we just do a straight up drop one. If it's not, it's a nothing, then the next time is that entry. In a current time list, if that is a thing, this is doing the same thing as advanced, where it's asking about the state of this. Then this is more like Here's a way to illustrate this. Maybe? Now, the first pass, if we have a current value, like this is like almost a recursive thing, but not quite. Then we need to do list.drop1, blah, 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 blah. If we don't have a current value, then it's just the head. But of course, current is a maybe of a value, which is exactly the one we don't want. Yeah, and then we have to do all of that stuff on all the head stuff. So what does that look like? If we have a current value, then we have to do still technically a maybe. Then we do list.head. Essentially all of this stuff. But it depends on what happened here. Or is this still a case of just we don't care? Because then it's list first time of and if it's nothing, then it is list of list. Yeah, that's kind of messy. Okay, so that advanced. And we still have had some debug logging in there. I need to reverse this. I might need to reverse this. The way worlds build up. Let's stat reverse. We still need a helper function there. Badlands age. Graphic age. And this really is just age. Haven't done anything else yet. All right, so this gives us mostly inline function calls. And some messy logic with some helper functions. Yes, this should really be up with the other stuff. All right, that was a whole bunch of code, even though I don't necessarily know if I really want it. Okay, control D doesn't work. Control D doesn't work. Thanks for playing. This is rebuild with passing time. Build with plain lists, passing time. Which I didn't particularly like that. I kind of don't want to do version that everything one big ordered data structure. That just seems a little bit too much. Rebuild worlds. What if we did a version Well, it'd take a bunch of setup to get the list of evaluation times. Would sort of streamline that. Or would the individual, or at some point we would call an individual function that was just a certain time. Well, that's kind of world merge. There's a certain time, but at some point we have to select the appropriate. Well, if it's just a certain time, it's only going to add one entry. Because once we've got the list of times, just like pick one and do that. So the next time is always just, well, it's going to be a list head, so it's still kind of a maybe. But maybe it's a list map of the times. See, the thing is, I don't necessarily want just a list map. Kind of like to be advancing the other lists as you go. So it might be something similar to this. Well, except maybe next time is just list.head times. And if that's ever out, then we're done. But it's not quite a list map because we have all the extra state. It's sort of a reduce over a really complicated state. Well, you know what, we're gonna have to deal with this at some point. Really, I need to be down to a particular time. Which is actually kind of, yeah, that just simplifies this case. And this is just a different way of saying that for the case where it's a list, and that was the head of the list. Rest. You're going to have to have some sort of. And this is almost just optimization to even drop these. I think we're going to have a thing that skips entries until it finds what would be the current value? Now I think these won't be the same functions. Because we don't have to care about the next value, so to speak. Current might be. We could structure this like we had before, where we do a couple lets. Say drop. No, because we need to keep entries. We can drop things that ended before. But we're sort of still looking at the first, or at the next entry to say that it did not qualify. So current might work. Does advance actually work? And we just don't need list next time? Because this does sort of drop while there. Doesn't really change a whole lot. It just puts a lot less pressure on getting everything perfect. Well, I guess the helper function thing was one of the things I didn't like about this. But I am going to have to do some very explicit logic on my time sequence. Which I guess has the advantage that it's easier to do things like defining how small of entries should be combined. Is it 1 millisecond apart? Is it 1 second apart? Is it 1 minute apart? So that's given a time list. Don't necessarily have a good place to put the print in here. And then we just have to have the thing that makes a time list. Right now, we only deal with, well, these functions don't deal with end times either. Oops. So you are going to be uh, list. So map, fold, filter, filter map. Over a list, flattening the results. Not sure that applies great. I know that we're going to have this dot map, dot start. That would be if every cat map would be if every command return a list. Now, I could probably do something like a list of these. Cat is individual values. Put two lists together, concatenate a bunch of lists. Maybe cat map would kind of work. No, cat map, it's that thing. Well, each entry in itself going to be a list. If you have the list of the lists, and we map list map over that, well, if we map list dot start over that, cat map. These should be straight up integers now. And then I want to do some post-processing, but this is a start. All right, does that even compile? Yug. Version. The version's value is the list version. Oh, right, I can't actually have a list of these things. I can have a list of the results of doing this, but I can't have a list of those. Argument is list POSIX. Oh, yeah. Well, yeah, it's only sort that needs that, so we can actually come on and do time dot POSIX to millis there instead of repeating it. Okay, that compiles. We could probably do something with this. Kinda done with some of this. Okay, that does not seem unreasonable. So now the real question is, what we want to do a time list, and how can we do it? Because I want to go through pairwise. This is probably going to end up being a recursive function. Or is it a fold? Or we're generating the new list? If my intermediate state has the last value and the list of output values, perhaps. So you are going to take, let's see, bold takes ABB. They're going to be an int. A int list int. Which means that we want to do tuple dot second on that. So we have a value, we have a last, and we have a accumulator. I guess last is, oh. Yeah, last is going to be the head of the list. I may have to reverse this. I guess the left, right should take care of that. Could be head of list, but then we have to deal with initial state regardless. We take the head. And I think I'm overdue to take a break. I'll be back in a few minutes. So we can... Oops. Luxtra got sucked up. Well, isn't that inconvenient?
I can live with that.
I'm still lagging. I'm putting everything too low.
No, but it's because you need to. How much RAM do you have?
8.
Alright, just go. Just go to settings, or I mean your control delete. If you go to there, you go to the details. You need to go not to.
Just there you go. Gotta soak it up. Mmm. Yummy. Uh-oh. Now I'm all sticky. Oh, thank you. Thanks, Mom.
All right, welcome back. So we want to compare two values at a time. That's going to depend on whether the cum is a last rest or an empty list. If it's an empty list, then we just return value. If there was a value, then we want to say I think I always forget how this works. Well, fold L is going to sort of naturally have the efficient way to iterate initially. I think, because left is sort of how you build up the list. The sorted order, but then I would have to reverse it myself. Actually, fold R probably just reverses it and then does it. So maybe fold R, which says that we are going to get things in descending order. So value is going to be the larger. And we start with the simplest thing. Now, until I get multiple lists, there's not going to be a whole heck of a lot here. In fact, I probably can't really test this on my current data set, really. If I start actually applying it to more things. But this will definitely catch the equal cases. Then we just return. Do I want the first time or the second time? We consider these as currently being start times. We probably want to take the going from the right. If we're going from the right, it would just be a cum. Else, it would be. Wait. If it's farther apart, then you can put it on there. List int AB. Oh, right, because I do that. I didn't. Time list int. Oh, you need an initial value. Okay, so that was the initial value of that. That way, I guess I got my. I guess it's last minus value. Right, if we're going from the right, because they were all negative. Okay, now you've. And we have remained our sorted order. That compressed nothing because we're not really applying this to other things. All right, so if this holds, we have an explicit way to handle merging that stuff. Unfortunately, the only one of these functions we save is this. We still have these slightly messy things here. Test this, I have to be applying this to other things. Explicit list of world break time. Map UI, right now, this is kind of a this is very test. I'm not even saving it. Or using it for anything. So probably we want to put this into our yeah, because we're gonna have to well, I could rebuild it every time we get it, because anytime something changes, I'm gonna rebuild that. I think I'm eventually going to want this for some UI feedback purposes. Now, not previously. Oh, interesting. Code changes kind of uses that. But we didn't have to have the actual type. An initial value is the thing we removed. Of that, and then we will have to come back and do it. Anytime we get arc, when we get arcs, when we get versions. Initial model. All right, so this did not type out nicely. I probably did world instead of list world. There we go. That's still being printed somewhere. Where are you being? I didn't take this out. You're being done twice. All right, so now when we get version data, okay, arc list, and objects received. Current arcs equal. This is a little bit messy because we have to map stuff out of remote data every time. Okay, well, the arcs we have. Versions we have to check from here. Model dot versions. Maybe I need some sort of helper function. Model dot versions of. Really, if it's data versions, and I think in every other case, it's empty array. Okay, so this. Okay, so my code changes also did not do. I don't have a good sense for how far apart these are in real world time, but I'm doing very, very small. Well, actually, if there are any near significant digits, that's pretty. 553, 556, 5569, 558, 5564, 6426, 39. 453, 6453. They're pretty close. Well, we are pretty sure it's not 2. Actually, we can totally make something happen here. Yeah, just a bit. Yeah, so it's a question of, do I want it to be within, well, actually, I should probably do like 1,000. Okay, nothing was actually within 1 second of each other. Maybe 1 minute. But beyond that, we're getting into things that happen like, well, in the same hour, the same change. Okay, we got something that was the same minute. And maybe there'd be more over arcs, I don't know. So this might actually want to extend that to minute window. Or like things that got pushed out at the same time. But even then, I don't know if the code and data changes get really pushed out at the same time. All right. The other thing is it's objects receive. And this is where I'm actually going to need a let. And worlds equal data rebuild worlds. code changes, versions. A model.arcs of maybe I need to have like a remote data.map or something. Oh, right, this is where I put the data wrapper on. Okay, not clear which came in first. That was about what we had before. Well, this is probably fewer lines here. But it looks like some of the arcs and versions were pretty close. Okay, so well, no, if I'm selecting arc, I'm going to select the arc. I'm not going to select the world. Selecting a time period, I'm going to select that definite time period. That would necessarily get you some of the model history stuff. I guess 10 minutes does kind of leave some room for really, if you're really fine browsing, to be off, but now I have not actually been checking. Got my reverse here. We're getting sensible results. You're a big boy. Are you the first one or the last one? You're the last one. Okay, yeah, we got all the object data in there. All right. So if we've proven that out somewhat, a little type thing was interesting, but kind of didn't like the way we had to statefully advance this before doing that. Hmm. Arguably, I could then use this as my data structure for the lists, but now we've got this weird other data structure. It does make some of those operations trivial. And then next time kind of disappears? Well, no, because we actually use it here. And then we ended up reusing these things. but losing this thing needed a helper function. This is, I would probably more code than what the JavaScript was. Current and advanced still ended up being slightly hairy things. And we're not dealing with end times yet. So we don't have our unknown periods. Now, well, the next step is going to be get that back to JavaScript land. Is that going to go smoothly? I don't know. Okay, so we still have this. Yeah, we sort of did that. We did that experiment. Yeah, I'm not going to be able to use this without the arc end time to pick the right map. So because age was very, very close to this, you defined arc, and was a POSIX. Well, by converting that, we were dealing with arcs here before. So this is one of those cases where we sort of have to put in a placeholder. Okay, that's mostly our output structure. Now age is, yeah, and we had this straight up literal. That's the actual end. Now, data time is a very, very specific thing, which, when we get into our world merge, data time is oh. Maybe I was, no, because We're eventually gonna have to. Oh, have I done fix up on this yet? I may have punted that. We're gonna have a start time. We're not gonna have an effectivity end time. So I guess that's where having the wrapper function is going to help. And I do this with code changes. End equals m time. Okay, for my age definitions, I bumped startup one. So that's not quite the same. Although if I made a function out of that, I could make it two separate steps. That's age.start, that's m time. This has nothing to do with m time. Is a list of ages or worlds. Although really, this just fix up end time only has to have an end time and a start time. Really. But it should work in practice. Uh, there's probably a way like that. Make this just an application? Is it like point free form? So the fix up end time version of this doesn't need that. Oh no, wait, fix up end time does. I'm thinking of fix up start time. And then also have fix up start time, just as long as we're making functions. Now you are more specifically an age-only thing. At least the same thing. This is just going to be a map. Oh, I guess this is still a function. And there's more happening in parallel. So I think as long as we do... I think I want these to reverse it. To not reverse it. Start time, because that uses the start time that was used. Okay. Something equals. Right. The syntax changes depending on the first of the following entries. Or oh, because you kind of changed what you are, what we call you, what you could be. Okay, and now this, well, make sure that looks sane. Ages, beta, end, Q4. Start POSIX 1 seems reasonable. See, I am not printing this out anywhere. Is that my notes? Yes. Oh, in order to throw this over to JavaScript, we're going to need an encoder. Which means name, POSIX, and data time generation. We're going to need encoders for all of this stuff, including spawns and biome sets. So that is not something we can do quickly to look at it. So that's our next step. Are we in a position to clean up debug? For the moment, rebuild world's time list. Each time we process, want you to look at that. Back. Mapping an error. All right, and then our next thing is going to be a whole bunch of encoders. All right, but that is like probably next time Monday, because I think there's going to be some One Life client changes to look at. Thanks for watching. Thanks to everybody who hosted me. What we got? All right, so this is about when I'm usually on. Looks like fifth function is back at his JavaScript renderer, which actually used to be pretty good about auto muting when you were live. I guess your new dashboard doesn't do that so well. Yeah, it was cool to hang out. Fifth function is working on 3D rendering in JavaScript. That's some more like down messy code. Yeah. Thanks for hanging out with me. Goodbye and until